to places. So critical thought, that is the beginning of mathematics. So it begins with pure thoughts, concepts such as sex. Oh, sex, a group of people, or a group of objects. To start with this, that is the core, the cell, in other words, the basic things. It is the beginning. So from cell, from sex, if sex does start behaving, then you start thinking, if you behave like this, you already must understand. Because, so, that's the foundation. We have sex, we have groups, we have fields, we have matrices, we have properties, and which was initially just all these things are developed initially as just intellectual systems. Many have no immediate applications. Many have no immediate applications. That's why it's somehow funny when you get someone say, what is the use of this now? That's not your business. Your business is to think about these things and see what are the structures, what are the things that they come with. Leave that application because there are people who take your concepts and apply it. So, when this thing started, there are no ready applications in mind of the people that develop this. So, it started from just things across. But history shows that all these things that are now useless, let me put in quotes, useless in those days, are now the cornerstone of innovations. That's the beauty of mathematics. For example, number theory. You don't show number, just look at the pattern of numbers in the days. People look at the pattern of numbers. But those numbers that was looked at the aspect of then, today false incorrect. Ensuring the clarity of our advance. What the how
can we share it in the group
for all these
is your link?
It's my link. Similarly, non-trivial one's curiosity is now indispensable in general relativity and GPS technology. Now, today, everybody can know where everybody is. On your phone like this, you can know things. Somebody's car is stolen in the Maiduguri, and on software, the trace to be Australia with that everybody moving around. What is this?
Com o João. É, o João.
So, all those things, unbelievably, people look at it, what is it talking about? What is it talking about? So today, the same thing is the foundation of GPS technology. Now, application has a natural progression. You can tell from application to application requires curiosity, persistence. The mathematicians must ask, they must ask some questions. What being that phenomena resembles this structure? That is the reason. Any structure to look at your study, it only depends on how you can think. There's something you are doing that only have a structure in real life that looks like this. They will not look at this and solve this. But if they try to control for that, you see that it's not only doing that, they are actually something you can use to understand. So, what real life phenomena resembles this structure? What real life phenomena resembles this sex? Union of sex. Is there anything real life that look at the union of sex? So, if you ask this question, then you have to mind it there. Oh, if you do like this, then let's look at the behavior of the sex theory. Let's now look at this video in the real station. This is the bedrock of everything we are building. Where can this model be deployed? Where can this model be deployed? If you ask this question, we will have the answer. The problem we have is that we don't ask questions. And we should ask questions. Anything we see, is it possible to bring it to reality? Yes, it is possible.
Some things that are not possible in the yesteryears are possible today. And many things that we see today are something that we think is not possible sometimes ago. So the cycle of abstraction, application, innovation is a cycle. Abstraction, application, innovation. Abstraction, application, innovation. Anything that is abstract yesterday, somebody look at it and try to see how can I apply it. After the application, somebody still look at the application and say, how can I innovate on it to get a better thing. So this is a cycle, and we should try to always build on that. This cycle, which is abstraction, application, innovation, is how mathematics propels to tighter progress. So this is always be a master. Now, I'll just bring us to one small thing that started not long ago. I'll just share the spotlight on matrices. Matrices as an emerging tool. Allow me to apply relatively new and facilitated structure in matrix theory. We call it matrices. This actually came in the year 2002. It's very, very new. When we see that in the matrix theory, we have seen what we call the 2x2 matrices, which all of us know about. It has four entries. Then we have a square matrix of about 3 by 3. It becomes, there are 9 entries there. Now the question arose. That's why I say ask question. The question is from we see matrices have 1 entry, we have matrices that have 4 entries, we have 2 entries, we have what happens if we have entry between the 2 by 2 and the 3 by 3? There is none like that. 2 by 2 and 3 by 3. Okay, let's look for another structure that will not have more than 4 entries, but have less than 9 entries. The idea of a matrix. Okay. That okay, we can arrange this thing in a different way. The arrangement is a bit problematic, but finally we say, let's arrange it like a rhombus. A rhombus arrangement. Like a cat. All these things. So we now have what we call matrices. It has 5 entries. And from there, it is just a pure mental exercise. Pure mental exercise. That was the expression, the notion of Neutral's passion. Effectively, we have a diamond-shaped object, which we call matrices. The pattern, rather than the traditional rectangular form, no, we don't talk of matrices, it's always a rectangular. 2 by 2, 3 by 3, it's not a square, so it's a special rectangle, where the length and the weight are the same. So, whether square or rectangle is still a rectangle, special one is the square. Now, when we have that, so this one now comes as a diamond. It doesn't fit in any known shape that we have. So, this geometric innovation gives us the new geometric operations, enabling mathematicians to address problems unsuited to classical matrix frameworks. There are problems that are not suited to the classical case of matrix frameworks. But now, people are now starting looking at matrices. If matrix cannot solve this problem, maybe matrix will do that. But initially, matrix came only as abstract reasoning. Several studies illustrates how matrices have been applied. I try to check through the internet to see. It's not just been applied to anything. I saw cryptography and code theory. They use matrices for cryptography now. Why? Because matrices are being used to design encryption systems, offering alternatives to classical matrix ciphers. Reason? Because there are no rectangular arrangement to reduce complexity that strengthens security, making them suitable for data protection in this digital age. From the beginning, we don't know what to do with matrices. But now, people are trying to use it for encryption. And they say it's much stronger than the encryption techniques in the classical matrix theory. Now, another thing is image processing and signal transformation. An image compression and reconstruction, matrix transformation provide an efficient coding skills. These are applications for medical imaging, satellite data transmission, and multimeter storage. Also, in decision science, in operational research, matrices help represent organizational decision variables. For instance, resource allocation, programs, involving hierarchies of constraints can be elegantly expressed in rotates form. Because you know, if you want to distribute things and that is a hierarchy, you can arrange them in rotates form so that the distributor will be at the hearts of rotations, and the layers that are supposed to be higher will be next, and next weaker, and it goes. This type of structure does not exist in matrix theory. For the rotates, you can arrange them in hierarchical form. So this, by extending linear algebra to new territory, rotates embody the very spirit of this lecture, and after concepts maturing into real world solutions. I will not talk about the victim of propagation, Professor Big. No lecture in his honor will be complete without acknowledging the remarkable career of Professor Osman Sumata. His profile of prolific research on heat and mass transfer in post-linear magnetohydrodynamics, boundary layer flow, and thermal regulation provided insight relevant to engineering, energy systems, and environmental studies. For example, his work on Newtonian heating has helped model thermal processes in industrial applications. His studies of energy flows have influenced designs in cooling systems, nuclear reactors, and geophysical explorations. His contribution to boundary conditions, we have the Riglets, the Newman, the Robin types, continue to inform both theoretical mathematics and engineering practice. Professor Basant Jha exemplifies how deep theoretical mastery, coupled with an eye for application, yield solutions with profound societal value. Mathematics as the driver of progress in Nigeria. We need to bring this thing to the home front. Nigeria stands at the crossroads of opportunity and challenges. Our society grapples with issues of energy, sustainability, infrastructure, healthcare, and security. Mathematics is not a luxury in addressing this. In fact, it is a necessity. So we should be able to bring this thing home to help us solve these challenges that face the country. Number one, in energy. Optimization models can improve the efficiency of our power grid and advance renewable energy integration. We have to bring in optimization, how we will use the available resources optimally and bring solutions to our energy problem. In agriculture, mathematical modeling can enhance integration, pest control, and predictions for company food security. Now we have when we go to agri, we have what we call the use mathematics a lot. When you see they want to work on the field, they have what we call complete randomized drug design. They use mathematics to design how to plant, and they will get the best result, the best thing, better than the current one they have. We also have the public health, mathematical epidemiology, and better prepare us for outbreaks. Before outbreaks, we always predict and prepare for it, going based on the trend, ensuring timely interventions. Security and ICT, cryptographic tools, including those based on process transformations, can safeguard national databases and transactions. And we have urban planning, operational research to optimize traffic flow, waste management, and housing development in our growing cities. By investing in mathematical research and applications, Nigeria can transform its challenges into opportunities for innovation. A call to our students, mathematicians. Dear students, you are peers to enrich intellectual heritage. Peers, I mean peers that you are going to inherit. You are here to this heritage. To study mathematics at American University is to step into a tradition that demands both rigor. So what I mean by rigor is that it is not easy. You cannot just think it's going to become easy. They say nothing good comes easily. So you are going to demand rigor and demand creativity. You have to go beyond the classroom. Whatever you are taught in the class, you will try to do your own and add more to it. Anybody that is only depending on the classroom is actually not doing justice to the work. You have to do, when they teach you 2 plus 2 is 4, and this is the way to do it, you try to see, and I do that way, and you get the same, I get the same answer. So it demands rigor, it demands creativity. I urge you, one, to appreciate abstraction. Appreciate abstraction. Why? Because it is abstract. It's only when you appreciate this abstraction that you know that it's very beautiful for you to use it for anything. So do not despise the theorem because it seems too theoretical or too abstract. Today, it's abstraction, maybe tomorrow, technological revolution. Number 2, you have to seek applications. As I said, continually, where does this concept fit in the real world? How can it be adapted to solve human problems? There is nothing you do in mathematics here that you cannot adapt to real life problems. Even if you don't know it now, you're not it now. By the time you persevere, you try to look at it and again, you will be able to see, oh, it looks like this structure. Therefore, you can get go ahead and a place to use it. So, seek application. Number 3, be innovative. Be innovative. Explore. It is good for us to explore. Anywhere we are, let's explore. Explore emerging structures like processes, and develop new methods, develop new algorithms, develop new frameworks. The future belongs to those who dare. You know, somebody say, I dare you. So I also dare you to develop, think. I dare you to be innovative. So the world, the future belongs to only those who dare. If you can dare, then you are going to get there. The future belongs to those who dare to think differently. Please, as a mathematician, you dare to think differently. That's what we are get the future. Then the next thing is collaborate across disciplines. We said in the beginning that mathematics is the queen of sciences. Now, means you cannot do this in isolation. You collaborate with chemists, that will collaborate with the biologists, collaborate with the geographers, collaborate with the medicines. Anywhere you collaborate with, mathematics will always find its place. If you collaborate with historians, you always get a place to fit. So you can collaborate with physicists, engineering, economics, medicine, and even social sciences. If you didn't understand the time of their story, you know where they're coming. Let them just tell you brief of what they are doing in their area. You just develop some models and way to solve the problem for them. And you will get a better result. Learn to communicate with colleagues in these areas so that you will be able to help their work. Last one I'll say is honor mentorship. Honor mentorship. As we honor our father here today, honor mentors. Anybody that you look at as a mentor, try always to honor them. When you honor them, you can get from there. If you don't honor somebody, you cannot get from that person. Anybody you honor is somebody that you can always go and say, please, I need this, or I don't understand this, and he will give you everything. Everything he has, you will get it. So honor mentorship. As a honor Professor today, remember that mathematics advances not only by the brilliance. There are some good students, very, very good, but they will not do places. But people who honor their mentors, you go to somebody, tell you something. It's like a mechanic that learned when they were doing the contact set and everything. It doesn't take anymore now. But if you honor your mentors, you go back and say, oh, the new product has come out, then you fit. So honor mentors. Try to advance, try to move. Don't just remain where you are. Anything you learn today, and also learn by tomorrow. So, all mentorship, you get people that have mentorship, guidance, and shared passion. I think that advances life. In conclusion, mathematics is the engine of progress. From the beauty of abstraction to the practicality of the applications. It serves as a bridge between thoughts and action, between the classroom and society. Structures like road process, I also mention road process because I'm only happy to mention it. Factors like road process remind us that innovation often arises when we dare to reorganize the familiar into new patterns. It's a dare to reorganize it. As we continue the journey in mathematics, take inspiration from Professor Jazz. His dedication to the subjects, his passion for education, and his unwavering commitment to mentoring younger scholars. Let us commit ourselves to ensuring that the mathematics we study and teach does not remain confined to the pages of textbooks, but translates into real-world solutions that uplift our society. Thank you.
How many years ago I was again for Professor Zaria? That was really uniting. Mathematics indeed is not just about numbers, but about shaping society in meaningful ways. One of the things Professor said was the future belongs to those who dare. So he's daring every one of us. So I'm saying for the young team. You deny that daring as well. So I'm daring one of us. Thank you very much, sir, for that wonderful speech. You don't have a person to be professor. He also said we should honor many cultures. So the next time God comes again, so also honor the man of the moment once again, please. Now let's say that professor. Thank you very much, sir. Thank you for all you do. We really appreciate you. Thank you very much. So for you, nobody, one day, the water is having one of us. One day, the work, what you do. So, thank you very much. Professor said a lot of things, so because of time, those of you that are meeting what he said, just give me one or two minutes to our room. Alright, thank you very much. Please, let's welcome another exciting lecture. Before we go, please, when the professor was giving his speech, we have one or two dignitaries that was there. Please, a round of applause as an acknowledged presence of Professor Zaria Singh. I don't teach you other citizens, something that I need to only also, let's have the presence of Dr. Yusuf Samuel. Thank you. Please, sir, let's have the presence of please, let's have the presence of next we have another exciting lecture on the thing that touches the future of our discipline. Mathematics beyond the classroom. Say it again. Mathematics beyond the classroom. Say classroom. Data application, research and career portraits. Please, let's welcome John Musa, to give us the details and vision of our second lecture. Let's see. Okay.
I'm giving the citation for next speaker. Dr. Zaria back his BSc 2014 from the Department of Mathematics. He was our coordinator I was at office one time where he was going to submit to us and results really thank you. Dr. Jimmy Yahya is a mathematician and a lecturer at Mathematical University Zaria. He holds a PhD in applied mathematics from King Monkus University of Technology, Nagpuri, Thailand. He has presented at conferences across Asia, Europe, and the Middle East, and served as a reviewer for several reputable mathematics journals. Let me just speak out of his awards for the sake of time. He received the National John PhD scholarship of the King Monkus University of Technology, Nagpuri, Bangkok, Thailand. Also, he received the bronze medal in the National Mathematics Competition for University Students, NAMS 2018. Also, he received awards from the National Mathematics Center, Abuja, Nigeria. With a standing ovation and the Department of Arts, can we join me together to welcome our next speaker? Dr. Jemilu Yahya.
Now I've become a photographer.
Mathematics beyond classroom, where applications, research frontiers, and career pathways. I use this particular topic because research is the government's worldwide. Presently, AI has become part of our lives. So, before I start to talk, I would like to give a little observation based on the person who presented my presentation. Actually, I graduated from this department in 2020. I came in here, I think, on 7th December 2010. I'm collecting my admission letter from I collected the registration block from IIT. It was the first lecturer I led of the department. It was the first lecturer, in fact, really opportunity to engage with the at that time. So, when we come, I was very scared for him because he always tell us what to do. What is that? I was so scared. In fact, up to the time we started the lecture of mathematics, up to the time I finished model level, I never visited any lecture office. I didn't visit any lecture office because of the way I was so scared of my lectures. Not because they are okay, but because of how the feelings that we have towards them. Perception. Yes, the perception we have towards them. At that time, actually, lecturers were so friendly, but when it comes to serious matter, you will know that you are talking to somebody who is very serious. But nowadays, you will see students banging your shoulder while taking the step in the department. So, thank you very much for the opportunity to meet. Despite that I am one of the youngest staff of the department, I was opportunity to be invited. So, good morning, respected professors, colleagues, and our dear students. Let me start with a quick question. Based on this topic, mathematics beyond the classroom, AI applications, research frontiers, and career pathways. How many of you have used Google Maps? YouTube, watch it. I want to see how much this. Well, you are already interacted with mathematics in action. Google Maps uses optimization to calculate the fastest routes. YouTube uses probability and statistics to recommend videos. While ChatGPT is powered by linear algebra, calculus, and optimization. And I'm going to explain this as we go in. This shows us one thing clearly. Mathematics is not just what we do in the classroom or exams. It is a living force, shaping technologies and industries around us. Today, I will speak to you on mathematics beyond the classroom, AI applications, research frontiers, and career pathways. Together, we will explore three key areas. The first one is how mathematics powers artificial intelligence, which is called AI, where current research frontiers lie. What career pathways are open to mathematics students like you? So, I will start with the first part, which is mathematics as the language of artificial intelligence. Artificial intelligence sounds like a branch of computer science, but in reality, it is at its heart. It is mathematics at work. For example, if you take linear algebra as an instance, neural networks are built on vectors, matrices, and transformations, which is clearly a linear algebra, right? The linear algebra that from flat numbers rather than teaching now. Take calculus, for example, also. The brilliant design and optimization techniques minimize errors functions during the integral methods. So, clearly, calculus play a vital role. Probability and statistics. Probability and statistics actually guide decision making under uncertainty. Whether in prediction, in predicting stock prices, or organizing speech. So, the part which I like most is optimization, which is my area. Every AI problem, from training a model to planning a route, boils down to finding the best solution. Always. Because, for example, now if you log into ChatGPT, you ask, okay, who is the best mathematician in Nigeria? AI will tell you that it is hard to take seconds before it will give you answer. It will analyze and find the best answer from the existing result that we have online. So what happens there is optimization. Try to find the best solution out of several possibilities. So the next time you solve a matrix problem or calculate a derivative, remember those very tools are powering self-driving cars, medical diagnosis systems, and even the apps on your mobile phones. On the real world applications of AI, which are driven by mathematics, I have this to say. Let's look at where mathematics in AI are transforming lives. Healthcare. AI systems analyze X-rays, predict disease outbreaks, and even assist in drug design using probability models. In finance, from detecting fraud to predicting stock market trends, mathematics is the backbone of fintech. Agriculture, optimization models are used to predict crop yields and crop pests, control pests. Transformation, self-driving cars, even though they are not so easy to see in Nigeria, but you will see them in Asia, Europe, and many places. So self-driving cars and delivery road optimizations rely on geometry, the geometry that was taught in our language. Graph theory, the graph theory that possibly the creative man of taught, and also control systems. So on the entertainment part, Netflix, TikTok, Facebook, Reels, all recommend content using linear algebra and probability. So try as much as possible to hold those foundations of mathematics very tightly. I remember when I was learning undergraduate studies, where is Mala was my classmate. I always said he would resume from first semester to second semester. I usually tell Abaka that I have covered at least 2-3 courses before we resume. I usually tell him this. Why I do this is because when you have a previous knowledge, at least you have read something, even though you do not understand clearly. When the lecturer comes to class, and as soon as he started saying, he begins to capture everything. I don't know whether you do that now, but it will really help because where I want to go, it will still backfire. When I went to China for engage, I think I called Dr. China. I called him to assist me on the study Fortran program, right? I called him. We were taught Fortran. I wanted to interact with the former department that why should we be teaching students Fortran? It's outdated. We should be teaching them like Python programming, something like, no. But it was when I went there, I realized that Fortran is not outdated. I was seriously wrong. Because the area in which I found myself in was mathematical optimization. And when I started my research, I had to give some numerical computations with regard to the problems I solved. And the existing result in the literature, researchers use Fortran in computing their results. So for me to initiate another work that is to either code by do the codings on either Python or MATLAB is going to take a very long period of time because I don't know how long time it took them to do that. So I have to seek for their assistant to give me the code. When they gave me the code, I had to install Fortran programming on my system. I spent almost 6 months trying to only install Fortran on my system. So please don't take what you have been taught and the as trash. They are very, very vital. In fact, they are key to your success. So, on this, I'll give you an example. Have you noticed how YouTube seems to know the exact next video you want to watch? I'm asking. Have you noticed how YouTube seems to know the exact next video you want to watch? Because sometimes you want to watch something. The next thing you want to watch to predict, to say next video, to show you their website. That's mathematics. Probability models predicting your preferences, combined with optimization to keep you engaged. So on the research frontiers, which this one basically is for the postgraduate students. AI is growing rapidly, but many open courses remain. And these are opportunities for research for the graduate students. So optimization frontiers design faster algorithms for training AI models. For example, in my area, in optimization, we use, as I told you, the existing author from the literature. I discovered that they use Fortran programming. So I tried to code it on MATLAB. But you know, MATLAB is not actually a resource. So after coding MATLAB in Thailand, now back to Nigeria, I have to use either Python or something that is free. So now I'm trying to do the coding on Python, and I'm not doing Python. So I have to learn it. So it is very important for students usually to think of what to do next, and how do we find something, how do we do something that is easier among many other possibilities. So optimization, example of this optimization process, the first one is explainable AI. Making AI decisions transparent so humans can understand and trust them. Because sometimes AI will give you answers that are not really in a good shape. So this requires deep mathematical modeling. Also, control AI, combining control mechanics with linear algebra to solve problems that classical computers cannot do. Mathematical modeling of human systems, using AI and mathematics to study epidemics, climate change, and even voting patterns. These are not just abstract ideas. They are such directions waiting for young mathematicians like you to explore. So the career pathways for mathematics students. Now let's talk about something I know excites many of you, your future career. With mathematics, your options are wide. Academic and research, continue to postgraduate studies, contribute to mathematical discoveries, and advance AI research. You must not be a computer scientist in order to develop AI. You can always try to apply it from the concept of mathematics that you study. Also, data science and machine learning, one of the most in-demand careers globally, requiring strong foundations in statistics and optimization. Finance and actuarial science, high-paying careers built on probability, risk analysis, and statistics. Engineering and technology, software development, system modeling, and optimization roles. Entrepreneurship, starting AI-driven businesses in health, agriculture, fintech, or education. The truth is, mathematics makes you versatile. You can fit into industries where logical reasoning and problem solving are highly valued. So, my advice to students, how can you prepare now as an undergraduate student? The first thing is, number one, master the fundamentals. What are the fundamentals? Pay attention to calculus. When I say calculus, I don't mean plus 105. Yes, because it's the only course that has that calculus on the title. When I say calculus, I mean many courses in this department. For example, Mass 105, Mass 201, Mass 203, Mass 204, Mass 301, Mass 303, and 407, and 401, exactly. So pay attention to this. Also, pay attention to linear algebra. When I say linear algebra, it's not only Mass 207 or Mass 208. Okay? Linear algebra, I need to say, you know what? 205, exactly 205, 206, and those that you see there. Then also optimization. Optimization, I think optimization related course that we taught is a part of the course of class 301. Remember, the certificate that was 301 and taught some part of optimization, as well as Mass 101. No, Mass 104. Mass 104. And then start 412, exactly. But now that I am here, I think maybe we are going to look into things and put optimization at 400 level as part of the latest process. Also, so I'd also be good at probability. Probability that you are taught at Mass 10, start 102, start 201, start 202. Pay attention to this because they play a better role. So they are your main tools actually. Also, the second one is learn to code. Don't just say, I'm a mathematician, I know how to solve problems. I'm sure the tomato don't waste time in solving problems like this. If you want to confirm, in most cases, I remember how I was in school, if you want to confirm the solution of our problem, we usually use calculator. And I remember also during Mass 103, if you want to confirm the proof of that long formula, usually we used to use calculator and punch it in order to show our answers before we come out of the exam. So try and be good at coding. Maybe it is Fortran, focus on that. If you know Fortran, it will be easier for you to know MATLAB. If you know MATLAB, it will be easier for you to know Python. So please try and pay attention to that. Languages like Python and MATLAB bring your mathematical models to life. Something that you can see not before. Also, the third one is engage in research early. Join small projects, seminars, or work with your lecturers to build experience. You must not always join. If you don't have money to start your masters, you can come to the department. The Tav Summit is there, the Shagaris are there. They are both there to mentor students. In their offices, you will see them solving problems. You can join. You must not pay. You can come and join them, start something. From the interest you pick there, you can now buy your form and start your masters. The third one is engage. The fourth one is look beyond the classroom. Read articles, attend workshops, and be curious about how it is used in the real world. Number 5 is stay flexible. AI and technology evolve fast. Adaptability is as important as knowledge. So try to adapt with what comes in. I remember I grew up in Chicago, so I know I used to go to Marbury. I used to see many professors there with their secretaries typing on typewriter. So when computer came, many of them refused to leave the typewriter. I think I was the one that I was given the last typewriter in that year, around 2005 or something. I went there, we were in option there, and I picked one typewriter because I wanted to learn computer at that time. So try to be flexible, don't be rigid on where to study. Focus on what is new, what is the trend, go for it, you can do it. So in conclusion, I have this motivational words to tell you. Let me conclude with this. Mathematics is not just about solving equations on paper. It is a passport. You know, if you want to travel out of the country, you can't travel out of the country without international passport. So mathematics is a passport. It's a passport. Mathematics, it is a passport to a world of opportunities. So try and grab this passport. Grab it and handle it with care. If you play with your passport, you may go to the airport and you cannot travel. So handle it with care. It is the foundation of artificial intelligence, the deliverer of global innovation, and the language of the future. But here is the key message I want you to remember. Don't just be consumers of technology. Be creators of it. So be part of those who develop these AIs. Don't just admire AI. Be part of those shaping it. Don't just wait for opportunities. Use your mathematical training to create them. The classroom is only the beginning. Beyond it lies a world waiting for your ideas, your research, and your innovation. So my other students, aim higher and bold. The world is moving fast, but with mathematics as your foundation, you are not just spectators, you are potential leaders of the future. Thank you very much.
Quisiera llamar a la foto por just like what Professor Iwakari told us, he tells us how Professor Jeremiah said we should be curious. He said look beyond the classroom. Be what? Curious. He also told us that mathematics is not just solving equation on paper, it is a passport. So you know if you go to the equation office, You know, you need the immigration officer now. These are the immigration officer now. So if you can get your passport, please tell me anything else in the question. Thank you very much for that wonderful lecture. It was really insightful. Really appreciate it. Alright, we have 5 to 7 minutes for question and answers. So you can use 10 minutes. So if you have questions on what Professor Theo Akimade presented and Dr. Jamilu Yaya, if you have your questions, please somebody should go around the microphone. So, okay, I want that man there. Yes, Mr. Daniel. Okay, we will sorry, sir. We are getting 2 questions. No, sorry, 4 questions. 2 from here and 2 from boys. So we have 3 boys. So please a consensus. One of you should not be that. Put your questions center. Okay, Professor.
Since organizations are extension of projects, governments and nations as related by then I also want that all of the motivation behind the implementation of or the consideration of boundaries, nations and non-terms.
Thank you very much. Actually, the motivation there. They said that I saw the person, a very original. That's from the square boundaries of the 1, which is just a number. They were able to move to and become vector 2 or a row vector. Now, they didn't see what happened. So they decided to work on it. When they work on it, they have it in a triangular arrangements. The metrics the caption, how the big on top, and the top basis. So it's like a triangular array of numbers about the base. This is on the base, one click. We call it matrix caption. Now, they can arrange the game such a way that it will start the peak and raise the blue base, the blue base and up. They call it nucleus. And based on that, to generate structures. What happened with what happened in the so thereafter, it was seeing that motivated me to say, oh, if we can have a grammar arrangement, then you have to union the action. What is going to give us? And when I put together, get 4 edges. What the top coincide. This is what I like this point place. Because 4 places is the same aspect. So I started thinking of what to do. So supposed to do something in the middle. To make 5 edges. Now, yes, it looks like globals now. Let me call it globals. Because it's a fix, because it's a fix, and the wrong point. So it's a solution of ask question. What if not? Whatever it gives you. No, what do you think about this? That when you ask a question and you try to explore to see the solution, it's okay that everybody comes out. Kudos. It's okay to come out. You have learned something that it is not possible this way. It is important research. Thank you very much.
Thank you very much, sir. Alright.
Good afternoon, everyone.
Yes, sir.
My question is to many of the speakers.
Okay.
And it's, why do we study mathematics?
Oh. Why do we study mathematics? I guess it's God that will answer that question.
Let's answer
because of bread and water. Because that comparison and God for better excellence. I would say one thing was saying all the time that from mathematics, you will see what's happening in society. And you try to bring it to the table. Solve the problem in a particular way. And try to bring it to solve the real life problem. If you talk about population dynamics, you will have a population growth and the rate. These are things that are real. Population of the population growth and the rate of this and the rate of population. So all this is not really good. Population of mass strength and mass delivery from growth and the rate of the current growth that are existing. Oh, change the population, the P, the T is varying as P, the current population. You know, so we learn mathematics so that we can solve the problem of the world. Eventually, as a solving, we have three benefits. That's the bread and butter. Because you will get some money, you have to feed yourself and take care of yourself. So the primary aim is to solve the problem of mankind. You want to build a car, you build mathematicians. In the workshop, they'll say, because of the timing of a car. Each calculation, they have to time the time the nose will drop the road. The time the air filter will supply air. The time the block will ignite. The three times must be well calculated and coordinated. Any slight miss in that thing, you see the characters, but it's missing because they are not well timed. So calculation every walk everywhere. So we learn mathematics to solve real life problems. The only thing that people ask is because we start abstracts. It doesn't look practical to us. But I said, it's only people who dare. I dare you. So this question will be answered for only those who dare to take to find out. But if you don't find out, you don't see. If people seek, only find. People don't seek, don't find. So you have to seek, you have to knock, so that they will open the door to you. So
Data is finished. Data. How? How? 2 gig is gone.
So I will answer this 2 minutes to tell you one time surprise you. Because I know what